Alright, welcome back. So finally, the most boring pathway in biochemistry has come to an end. So in this video, we're going to do steps 9, 10, and 11. So in the last video, we ended with the molecule fructose 1,6-bisphosphate. So I just rewrote it in a different formation. This was how I wrote it in the last video. So all I just did is drew it in a ring-like structure. So here's what we're going to do. We're going to use the enzyme fructose bisphosphatase. And what we're going to do is we're going to shred off the phosphate from carbon number 1. So here we have the phosphate right here. And in the new molecule, which will become fructose 6-phosphate, we are left with a CH2OH group here on carbon number 1, and the phosphate still remains on carbon number 6. So we just shred off the phosphate group on carbon number 1. With that, we are going to use water, and what water is going to do is going to add an H, a hydrogen, onto carbon number 1. So it bonds to the oxygen. So now we have a CH2OH. Now the phosphate that leaves is from carbon number 1 right there. Pretty simple. So that's what fructose bisphosphatase does, is it basically just rips off the phosphate group from carbon number 1, and the water adds a hydrogen onto carbon number 1. That's it. Now step 10. Step 10, we have our fructose 6-phosphate. And what we're going to do is we're going to use the enzyme phosphoglucose isomerase. And what this is going to do is essentially shift the carbon that was carbon number 1, which was not on the ring, and shove it into the ring. And so you can see here, this ring now has a 5-carbon ring. Yes, glucose 6-phosphate is 6 carbons, but in the ring itself is 5 carbons. And one of them, carbon number 6, is outside the ring. Attached to the ring, but on the outside, not part of the actual ring itself. So fructose 6-phosphate has 4 carbons in the ring because there's carbon number 1 and carbon number 6 are outside the ring, attached to the ring, but on the outside, so not actually part of the ring. And what we're going to do is we're going to take carbon number 1 and put it in the ring. And what we're going to do is we're going to move everything down around in the ring. So it's basically like a huge cycle. All we're just doing is pushing it down, and then everything else moves around. So now the only thing left in the ring, or rather, the only thing that's bonded to the ring and not actually on the ring is carbon number 6 and the phosphate group. So you can see that the carbon number 1, which will be right here, let me just draw carbon number 1 here, is now here. So all we just did is moved it into the ring. And that's all we're doing here. So, and that uses phosphoglucose isomerase. This is an isomer. Now, step 11, the end. So here's what we're going to do. We're going to use glucose 6-phosphate and we're going to use the enzyme glucose 6-phosphatase. Remember in glycolysis, we use the enzyme hexokinase. It's not the same enzyme. It's glucose 6-phosphatase. So on the exam, which I'm going to post probably in the next video, I'll make a huge biochemistry midterm. And I want to warn you guys, it's going to be hard. But I did it on purpose, right? Because for example, let's just do the hard stuff now. I want to give you the hard exam. We're going to go through it together. But this is going to prepare you so you can get an A on the real thing. Make the mistakes now so you don't make them in the actual midterm in your course. But also, think about this. If you can do the hard problems, you can do the easy ones, right? That's the mentality behind it. And I'll also post some MCAT questions as well on that midterm. So just in case if anyone's taking the MCAT, this will benefit you as well. So here's what we're going to do. We're going to do the exact same thing we did in step 9, is shred off the phosphate group. But instead of from carbon number 1, it's going to be on carbon number 6, because that's where the phosphate group is left. So here and here, right? So the phosphate group goes bye-bye. It's gone. And we are left with CH2OH, and that OH, the hydrogen, comes from the water. So we are adding water in this reaction, and this is what's going to turn basically the OH group here. Now, and the phosphate group that leaves is from the phosphate group we just shredded off. So now we got back to glucose. There we go. So this is the end of gluconeogenesis. If you found this video helpful, please like and subscribe. Until next time, later.